Continuing with the particle in the infinite square well, we have the energy states, and now let's return to the wave function. So we saw that the solution was psi x is equal to some constant a times sine of kx. And we know what k, the wave number, is now. It is n pi over L, and that's multiplied by x. Okay, but we still don't know what a is. However, we have the normalization constraint that we had from the Born rule, which we can write up here. And so again, that was integrating from minus infinity to infinity over all space of the square of the wave function should be equal to 1. Now this infinite potential well simplifies the issue because those points at 0 and at L, the boundary, where the potential goes to infinity, means that the wave function really has to go to 0 at those points. And so the particle can only be found from 0 to L. So that makes life easier. So we can now put that in, that we have from 0 to L, and then we can just put in that psi squared is a squared sine squared of n pi x over L dx is equal to 1. Okay, now how do we do this integral? Well, we can first go from a sine squared to a cosine of 2 times the angle using the double angle formula, which I'll write here. So cosine of 2 times this angle is 1 minus 2 sine squared theta. So in other words, sine squared theta is equal to 1 minus cosine of 2 theta, all divided by 2, where theta is equal to this argument, n pi x over L. All right, the other thing that we can do is when we substitute in, we see that we have that 1/2 minus 1/2 cosine of 2 times the angle. And since we have integration, we can think about this as breaking that integral into 2 parts. And you can do that for addition and substitution. And that then will make it quite simple. So let's do that. So we bring the constant that we want to solve for out front, a over 2, a squared over 2. And that first term then is just the integral from 0 to L of 1. So that's that term. And then we have the term that involves the cosine. So that's now cosine of 2 times n pi x over L dx, this whole thing is in brackets, is equal to 1. All right, so now the integrals, well, that first one is pretty simple. That just gives you x, and then when you evaluate it, you get an L. So that first term is just a squared times L over 2. The second one is a little bit more tricky because you actually have to use substitution, since there's the cosine is n pi x over L, and we're integrating x, so the 2n pi over L come out. And you get a squared over 2 times this L over 2 pi n multiplied by the cosine becomes a sine of 2n pi. And that whole thing is equal to 1.